They say walking is the simplest exercise, effortless, gentle, harmless. But inside your body, every step you take is a silent negotiation between fuel systems, a metabolic conversation most people never hear. Your muscles are not passive. They don't just move, they calculate, they adapt, they switch. From the first moment your foot lifts off the ground, your cells are already deciding, do we burn sugar or do we burn fat? And the answer changes, minute by minute, step by step, based on how long you walk, how fast, and what you ate hours ago. This is not about weight loss. This is about understanding what your body is quietly doing while you move. Let's begin. The first 5 minutes, immediate fuel activation. Your body does not start from zero. The moment you begin walking, even at a leisurely pace, your muscles demand energy. And the body's first response is instant. It reaches for glucose. Not the glucose you just ate, not the fat stored under your skin, but the glucose already inside your muscle cells stored as glycogen, a compact, rapid-access fuel reserve. Think of glycogen as the body's emergency battery. It doesn't need oxygen. It doesn't need complex breakdown. It simply splits apart and releases energy within seconds. Your heart rate climbs slightly, blood flow increases, muscle fibers contract in rhythm, and for the first 3 to 5 minutes, glucose is the dominant fuel. But here's what most people don't realize. This phase is not about endurance, it's about activation. Your body is waking up its aerobic system, the slower, oxygen-dependent engine that burns fat. During this window, your lungs pull in more air. Your mitochondria, the energy factories inside every cell, begin spinning up their machinery. Enzymes are released, pathways are primed. You feel nothing unusual, you're just walking. But beneath the surface, a metabolic transition is already beginning. The crossover point. When fat enters the equation, between minute 10 and minute 20, something shifts. Your breathing steadies, your pace feels easier, and deep inside your muscles, a new fuel source is being unlocked. Fat. This is called the crossover point, the moment when fat oxidation rises and glucose use begins to decline. It doesn't happen suddenly, it's gradual, a curve, not a switch. Fat is stored throughout your body, under the skin, around organs, inside muscle tissue. But unlike glucose, fat cannot be burned quickly. It requires oxygen, it requires time. It requires a series of chemical reactions that convert triglycerides into usable energy. At low walking speeds, roughly 2 to 3 miles per hour, your muscles don't need explosive power. They need sustained power, and fat provides exactly that. As you continue walking, enzymes like hormone-sensitive lipase begin breaking down fat cells. Fatty acids are released into the bloodstream, carried to muscle mitochondria, and fed into a process called beta oxidation. This is your body's long-range fuel system. But here's the nuance. Even as fat burning increases, glucose never stops completely. Your body uses both, simultaneously. The ratio just shifts. At rest, you might burn 60% fat, 40% glucose. During light walking, that might flip to 70% fat, 30% glucose. The longer you walk, the deeper the shift goes. What controls the switch? The metabolic decision makers. Your body doesn't guess, it calculates. The fuel you burn during a walk is determined by a web of biological signals: hormones, enzymes, oxygen levels, and muscle glycogen stores. Insulin is one of the gatekeepers. When insulin is high, usually after eating carbohydrates, your body favors glucose. Fat burning is suppressed, but as insulin drops over time, the body becomes more willing to tap into fat reserves. Cortisol and adrenaline also play a role. Even mild physical activity triggers small releases of these hormones, which signal fat cells to release stored energy. Then there's oxygen. Fat requires roughly 10% more oxygen to burn than glucose does. If you're walking slowly and breathing comfortably, oxygen is abundant. Fat oxidation thrives. But if you speed up, if your muscles suddenly need more energy, the body shifts back toward glucose, which burns faster. Glycogen levels matter too. If your muscle glycogen is low, say after fasting overnight, your body accelerates fat burning earlier. If glycogen is topped off from a recent meal, the crossover happens later. And finally, there's training. Regular walkers develop more mitochondria, more fat-burning enzymes, and greater efficiency. Their bodies learn to access fat sooner and sustain it longer. This is metabolic flexibility, not a fixed system, but an adaptive one, shaped by what you eat, how you move, and how often. The myth of the fat-burning zone. What science actually shows, you've probably heard of the fat-burning zone. The idea is simple. Walk at a slow, easy pace, and your body burns more fat. Walk faster, then you burn more sugar. And technically, this is true. At very low intensities, fat contributes a higher percentage of total energy. But here's the part that gets lost. Total energy expenditure matters more than percentage. Let's compare two scenarios. Scenario 1. You walk slowly for 30 minutes. Your body burns 100 calories, 70% from fat, 30% from glucose. That's 70 calories from fat. Scenario 2. You walk briskly for 30 minutes. Your body burns 200 calories, 50% from fat, 50% from glucose. That's 100 calories from fat. You burned more fat at the higher intensity, even though the percentage was lower. This is why exercise scientists emphasize total caloric burn, not just fuel type, but there's another layer. Walking at low intensity is sustainable. You can do it longer, more frequently, without fatigue or recovery demands. And over weeks and months, that consistency compounds. The myth isn't that fat burning happens during slow walking. It does. The myth is that it's the only way or the best way. Your body's more flexible than that. What happens after 30 minutes, deep fat oxidation mode? At 30 minutes, something settles. Your breathing is rhythmic. Your heart rate is stable. Your muscles have found their groove. And inside your cells, fat oxidation is now running at full capacity. By this point, muscle glycogen has dropped slightly, not depleted, but reduced. Insulin levels are low. Fatty acids are flowing steadily from fat tissue into the bloodstream and into muscle mitochondria. This is the body's endurance mode. If you continue walking for 45 minutes, 60 minutes, or longer, fat remains the dominant fuel. Glucose is still used, but sparingly, reserved for essential functions like brain activity and red blood cell energy. Interestingly, this is also when intramuscular triglycerides come into play. These are tiny fat droplets stored directly inside muscle fibers, positioned near mitochondria for rapid access. Trained individuals, people who walk or exercise regularly, store more of these droplets and use them more efficiently. It's one reason why regular walkers feel less fatigued over time. But even untrained individuals can access this state. It just takes a little longer to get there. This is not about pushing hard, it's about staying steady. And the longer you stay steady, the deeper your body leans into fat as fuel. The role of timing and food fasted versus fed walking. Your last meal matters. If you walk 2 hours after eating a carbohydrate-rich meal, while your muscles will burn primarily glucose, insulin is still elevated. Glycogen stores are full, fat oxidation is suppressed. But if you walk first thing in the morning, before eating, your body behaves differently. Overnight, insulin drops. Glycogen stores deplete slightly. And when you start moving, your body has no choice but to access fat sooner. This is why fasted walking has become a popular concept. Not because it burns dramatically more fat in a single session, but because it trains the body to become more efficient at using fat as fuel. Studies show that people who regularly exercise in a fasted state develop greater mitochondrial density, improved fat oxidation enzymes, and enhanced metabolic flexibility. But there's a limit. If glycogen is too low, if you're underfed or over-restricted, the body may begin breaking down muscle protein for fuel. This is not fat burning. This is survival. The sweet spot is mild glycogen depletion, not starvation, but a state where the body is encouraged to adapt without being overwhelmed. For most people, a casual morning walk before breakfast achieves this naturally. No extreme fasting required, just timing. Long-term metabolic adaptation. How walking rewires your fuel system. Your body learns. If you walk regularly, 3 times a week, 5 times a week, daily, Your metabolism begins to adapt at the cellular level. Mitochondria multiply. These tiny organelles responsible for burning fat and producing energy increase in number and size. More mitochondria means more capacity to oxidize fat. Enzymes upregulate. Proteins like CPT1, carnitine palmitoyltransferase, and AMPK, AMP-activated protein kinase, become more abundant, speeding up the process of fat breakdown and transport. Capillary density improves. More blood vessels form around muscle fibers, delivering oxygen and nutrients more efficiently, which supports fat oxidation. Insulin sensitivity increases. Your muscles become better at responding to insulin, meaning glucose is stored efficiently and fat burning is less inhibited. This is metabolic flexibility, the ability to switch between fuel sources smoothly, without lag, without reliance on one system. It doesn't happen overnight, but it accumulates, and it doesn't require intensity. It requires consistency. A 30-minute walk today won't transform your metabolism, but 100 walks over 3 months will. The body doesn't reward extremes. It rewards repetition. Your body is not a machine with one setting. It is an adaptive system, constantly reading signals, adjusting fuel sources, and responding to how you move, how you eat, and how often you rest. When you walk, you are not just burning calories. You are training your cells to become more efficient. You are teaching your mitochondria to access fat. You are reshaping the invisible systems that govern energy, endurance, and resilience. The switch from glucose to fat is not instant. It is gradual, layered, and controlled by biology, not willpower. Understanding this doesn't require a lab. It requires